Okay, let's talk about projections of points. Projections of points or orthographic projections of points. For example, let's say this is horizontal plane, this is vertical plane, this is point A. Let's say the distance from vertical plane is x, or point A is x distance in front of VP, and let's say y distance above HP. Okay, now we are going to draw its front view and top view. For front view, we are supposed to look in this direction, and for top view we need to look in this direction. This is horizontal plane, this is vertical plane, and intersection of those two is this xy line. In two-dimensional representation, that dot is going to become this xy line. Now when you look in the front direction to draw its front view will be projected over here. Front view will be projected on this vertical plane. The point A is above HP by distance y, so its front view will be above xy line and the distance is y. So let's say this is front view of the point, and this distance is y. Okay, now on this vertical projector somewhere you are going to get its top view also. So for top view, look in the top direction. It will be projected on this horizontal plane. Point A is x distance in front of vertical plane, so this is top view and it will be at a distance of x from xy. But we know that whenever any view appears on a horizontal plane, the plane is to be rotated in clockwise direction by 90 degree. So the top view that was appearing in front of xy line at a distance x, it will be shifted below xy line and the distance is going to be same x. So on this projector of the front view, you will get top view at a distance of x. The distance from xy line is going to be x. And in case of projections of points, if object is denoted by A, then its front view is going to be denoted by A dash and top view is going to be denoted by A. So this is our A dash and this is our A. Now consider there is a point B located in the second quadrant. This distance is x and this distance is y. This is our horizontal plane, this is vertical plane, and intersection of those two xy line. Now to draw front view and to draw top view. So when you look in the front direction, the front view will be projected over here. Distance above HP is Y. Same distance will be considered for front view. So this is going to be B dash, front view denoted by B dash, and this distance is going to be Y. To draw top view will be projected over here. Distance from vertical plane is X. Same distance will be taken for top view. It is appearing on HP. So when you rotate the HP in clockwise direction by 90 degree, this top view will get shifted over here and distance will be same as that of X. So in case of this second quadrant, this is going to be top view and this distance is going to be X. So B dash front view and B is the top view. Now let's assume the object is located in the third quadrant. Let's say point is C. This distance is Y and this distance is X. This is XY line. Now this is front view direction and this is top view direction. So front view, it will appear over here. This is our XY line. So front view will appear below XY line by distance of Y. So this distance is Y, and on the projector through this C dash, let's see where top view is going to be located. So when you look in the top direction, the top view of this point will be located on this horizontal plane. The distance from vertical plane is X, so same distance will be taken for top view. Now top view is appearing on HP, so it has to be rotated in clockwise direction by 90 degree. So this top view will get shifted over here and this same distance X will be carry forward. So on the same projector of C dash, you will get top view of the point C at a distance of X. So this is front view and this is top view. In case of fourth quadrant, let's say this is point D. This distance is X. This distance is Y. This is XY line. This is horizontal plane and this is vertical plane. Now this is direction for the front view and this is direction for the top view. Now when you draw its front view, it will appear over here. So this is front view. The point is at a distance of X below HP, so same distance will be considered. So this is XY line below XY line at a distance of X. you will get the D dash, that is front view, and when you draw its top view it will be located over here. Distance from vertical plane is y, so same distance will be taken for the top view. Now it is appearing on the HP, so rotate that plane in clockwise by 90 degree, so the top view will get shifted again below xy and distance is going to be y. So on the same projector of this D, at a distance of y, you will get the top view. This is front view and this is top view. Now the important part, when you are drawing front view, we know this is direction of the front view. Whether object placed over here or over here, its front view is going to appear on vertical plane at the same distance, because the distance of, let's say this is point A, point B, point C, the distance of all the point with respect to horizontal plane is same. So front view is nothing but the relation of the object with respect to HP, the relation with respect to VP. Say the distance between A and vertical plane is different, distance between B and vertical plane is different, distance between C and vertical plane is different, but their front view is appearing at the same position because the position of all those points with respect to horizontal plane is same. Okay, similarly, if you consider a top view, let's say this is point C, this is D, this is E, the top view of all the points is going to appear over here. If you look at the distance of all the point with respect to HP, it is different, but as long as the relation of all those points with respect to vertical remains unaltered, the top view is going to remain unchanged. So front view is nothing but a relation of object with respect to HP, and top view is going to be relation of object with respect to VP.